What is definition of multiplication? It is repeated addition. Say I have a number 2. I have a number 2 and 2 plus 2 equals 4. Then again 2 plus 2 plus 2, it equals 6. 4 times 2 plus 2 plus 2 plus 2 equals 8. If I keep adding 2, next I get 10, then I get 12, then I get 14. So I can see 2 plus 2 equals 4. It is 2 added twice. 4 equals 2 added twice. This is the concept of multiplication. If any number is added twice, it is the same as 2 times that number or twice that number. So 2 times 2 equals 4. It is the same thing as 2 plus 2 equals 4. Similarly, if a number is added 3 times or thrice, then it equals 3 times that number. 3 times 2 or thrice that number. This equals 6. Both equal 6. Similarly, if a number is added 4 times, the same number is added 4 times, it equals 4 times that number. Multiply two numbers. Say I have two numbers 5 and 4. So I multiply them. When I multiply them, the answer is the product of the two numbers. So the product is, I denote the product as 5 times 4. This is the sign which denotes multiplication. And this equals 5 times 4. So it is 4 plus 4 plus 4 plus 4 plus 4 equals 20. This also equals 20. It is the same thing. 5 times 4 is the same thing as 4 times 5. This also equals 20, and this is the same thing as 5 plus 5 plus 5 plus 5. This equals 20. So I denote the multiplication with a cross sign in between. This is multiplication 4 times 5. I can also write it like this sign in between, or in a parenthesis. Or I can denote it like this, the other way around. 5 times 4. This is also 5 times 4. And this is also 5 times 4. Like I'm writing it in a parenthesis. So 4 cross 5. And these are the different ways I denote multiplication. Up till now, I have gone through what is multiplication. But when I have integers, some are of the same sign and some are of the opposite sign. So you have to learn the rules of multiplication. Let's go through the sign of answer when 2 or 3 integers are multiplied. First of all, the rules. If I have two integers, either they can be positive or negative. So what sign does the answer take? 4 points to remember here. The two integers are with the following signs. If both of them are positive, the answer is positive. If two integers, both of them are negative, they are multiplied, so the answer is positive. So if the sign of the numbers being multiplied is the same, the answer is always positive. Whereas if one is positive, the other is negative, or this way negative and positive, if they are of the opposite signs, then the sign of the answer is negative. Let's see an example. I have two numbers 10 and 3. So 10 times 3 equals 30 and negative 10 times negative 3 again equals positive 30. Whereas negative 10 times 3 equals negative 30 and 10 times negative 3 equals negative 30. So we learned for two numbers. But sometimes we have more than two numbers. Say I take the example of three numbers. And the three numbers are of different signs. So some can, of the three numbers, either both can be positive or two can be negative or all the three can be negative. So let's check out the different combinations. If I have this particular combination, negative 2 times negative 3 times 4. So two numbers are negative and two negatives make a positive. These two negatives make a positive, and here I have a positive with 4. So positive and positive same sign, so the answer will be positive and it is equal to 24. Again here two negatives and one positive. So the answer is 24. Same thing here, two negatives, which is -2 and -4, and 3 is positive. So the answer is equal to 24. Here in this particular row, I have only one number which is negative and two are positive. And since I have one negative, so these two positives will give a positive answer. And this positive multiplied by negative will give a negative answer. So -2 times 3 times 4 equals -24. Again this also equals, because only one number is negative, so this also equals -24. And again here one number is negative, which is 3, so this also is equal to -24. And here if I have three numbers, all the three are negative. -2 times -3 times 4, -4. So two negatives make one positive, and here I have a negative in 4. So again positive and negative is being multiplied. So the answer is -24. And here the three are positive, so the answer is 24. Right? So, and when I multiply a number with 0, the answer is always equal to 0. When I multiply a number with 1, 5 is multiplied with 1. So it gives the same number itself, which is 5. That is why 1 is called as a multiplicative identity. Because when I multiply a number with 1, I will get the same number as an answer. And when I multiply a number with -1, I get the opposite of that number. That is -5 I get over here, the mirror image of the number on the number line, which is on the other side of 0. Right? Now that you know what is multiplication, I will explore more and do multiplication of two-digit numbers. I have various cases. First, I have the numbers 23 and 32. The answer of their multiplication is 736. So these cases I have. When I have -23 times -32, the answer is 736. When I have -23 times 32, I have -736. And in this case 23 times -32, again -736. But now let us find out how to get the actual answer 736 by multiplying these two numbers. So how do I do it? I write the numbers one below the other, so that the ones come one below the other and the tens come one below the other in one line. And then I form partial products. So the first partial product is 23 times 2. This 32, I have 2 in the units place, and I multiply this 2 with 23. So first, to multiply 2 with 23, I multiply 2 with 3. So 23 times 2. So first 2 is multiplied with 3, which is a digit in the ones place. So 2 times 3 equals 6. And that 6 I write in this ones place over here in the answer. Then 2 times 2. 2 times 2 equals 4. I write 4 in the tens place. So this is the first partial product. The second partial product, I multiply 23 with 3. But 3 is at the tens place. So in effect, I'm not multiplying 23 with 3, but 23 I'm multiplying with 30. So to account for this 0, I write 0 as a placeholder in the second line, which is the where I'm going to write the second partial product. So to account for this 30, I write a 0 as a placeholder over here below 6, below the units place. And then I multiply 3 with the digit in the units place in this number, which is 3 times 3 equals 9. So 9 comes here, and then 3 times 2 equals 6. So 6 is over here. So this is the second partial product, and to get the final answer, I add these two. I add these two and I add the units place. 6 plus 0 equals 6. 4 plus 9 equals 13. So 3 comes at the tens place and 1 is carried over to the hundreds. And 1 plus 6 equals 7. So the answer is 736. The next number, instead of 23 and 32, I have 27 and 39. So again, I go through the various cases. If both are positive, the answer is 1053. If both are negative, the answer is again 1053. And if one is negative and one is positive, so the answer is negative 1053. Here also the answer is negative 1053. Now let's learn how to find out the actual answer. So the same thing, I first find out the partial products. So first I multiply 27 times 9. So first 7 times the digit in the units place in this number, which is 9 times 7 equals 63. But 63 has tens and units. But here in the partial product, in the units, I can write only one number, which is 3, which is over here. But this 6 I carry over here. And then the next is 9 times 2 equals 18. This 9 times 2. This equals 18. And this carried over 6 I add to 18, which equals 24. So 4 comes in the tens place and this 2 comes in the hundreds place. That is the first partial product. Then the next I have to multiply 27 with 3, but not 3 actually, 27 times 30. So I write 0 as a placeholder here in the units place. And then the first product is 3 times 7, which equals 21. But here I can write only 1. And this 2 I carry over here. And then 3 times 2, which equals 6. And this carried over 2 I add to 6. It equals 8. So I write 8 in the hundreds place and then add the two partial products. So 3 plus 0 equals 3. 4 plus 1 equals 5. 2 plus 8 equals 10. 0 comes in the hundreds and 1 in the thousands. So the answer is 1053 for the multiplication of 27 and 39. So now I try out 3-digit multiplication and I have two numbers, 659 times 128. Just as in two-digit multiplication, in 3-digit multiplication also I write the numbers one below the other. The ones come one below the other, the tens come one below the other, and the hundreds come one below the other. So there are 3 digits in this number 128, and each of the 3 digits I have to multiply with the number 659. So the three partial products are 659 times 8. That is, the first digit is multiplied with 659. Then the second partial product is 659 times 2. 2 in the tens place is multiplied with 659. And the third is 659 times 1, which is 1 in the hundreds place is multiplied with 659. Now come to the first partial product. In that I have to multiply these two numbers. But what I am doing in effect is multiplying 8 with each of the numbers contained in 659. So first I do 8 times 9. That is 8 times 9 equals 72. So it has tens and ones, but here in the ones I can write only one digit. So I write 2 and the 7 is carried over to the tens. Then I do 8 times 5, the next digit. 8 times 5 equals 40 and this carried over 7 I add to 40, which equals 47. So again in the tens I can write only one digit, which is 7, and then I carry over this 4 to the hundreds. Then I do the third digit. 8 times 6 equals 48, and this carried over 4 I add to 48, so it will become 48 plus 4 equals 52. And 2 I can write in the hundreds place, only one digit, and the next digit comes in the thousands place. So this is the first partial product. The next partial product is 659 times 2. But 2 is in the tens place. So in effect what I'm doing is 659 times 20. So to make up for that, in the second partial product, in the ones place, I keep 0 as a placeholder. Then I multiply 2 with each of the digits of 659. So 2 times 9 equals 18. but only one digit can come in the tens place, which is 8, and this 1 is carried over here in the tens. And then I have the next multiplication, 2 times 5, which is 2 times 5 equals 10. This carried over 1 is added to 10, so 10 plus 1 equals 11. But only one digit can come in the hundreds place, which I write 1 over here, and this 1 is carried over here. The next multiplication is 2 times 6. So 2 times 6 equals 12, and this carried over 1 I add to 12, so it is 12 plus 1 equals 13, which only one digit I can write in the thousands place, which is 3, and 1 comes in the 10,000s place. This is the second partial product. The third partial product is 659 times 1, but actually I am doing 659 times 100, as 1 is in the hundreds place. So actually 659 times 1 equals 659, but this equals 659, it equals 65,900. So here in the third partial product, I write two zeros as placeholders, and then I write down this product. 9 comes in the hundreds, 5 comes in the thousands, and 6 comes in the uh, 10,000s. Then I add the three partial products. So the ones I add all together, 2 plus 0 plus 0 equals 2. In the final product, 2 comes in the ones place. Then in the tens, I have 7 plus 8 plus 0 equals 15. But only one digit can come in the tens place, so 5. And this 1 is carried over. Then in the hundreds, I have 1 plus 2 plus 1 plus 9. It equals 13. So 3 comes here in the hundreds place and 1 is carried over. Then in the thousands place, I have 1 plus 5 plus 3 plus 5, which equals 14. So 4 comes in the thousands place and 1 is carried over to the 10,000s place. And 10,000s place, these three digits are added. The answer is 8. So the final answer is 84,352. Next, let's try the next sums in multiplication. The first is 45 times 8. It is pretty simple. So I have to multiply 8 with each digit in 45. So first I do 8 times 5 equals 40. So in the ones place 0 comes and this is carried over in tens. Then 8 times 4 equals 32. This carried over 4 is added to 32, and 32 plus 4 equals 36. So only one digit can come in the tens, which is 6, and this 3 comes in the hundreds, and the product of 45 and 8 equals 360. The next is 765 times 4. So again 4 has to be multiplied with each digit in 765. The first digit is 5. So 4 times 5 equals 20. And only one digit can come in the ones place of the product, which is this digit in the ones of the product. So it is 0, and this 2 is carried over. Then 4 is multiplied with the next digit, that is 6. So 4 times 6 equals 24, and this carried over 2 is added to 24. So 24 plus 2 equals 26. 24 plus 2 equals 26. And here 6 is written in the tens place because only one digit can come in the tens place, and this 2 is carried over. Then 4 times the digit in the hundreds place. So 4 times 7 equals 28, and this carried over 2 is added to 28. So 28 plus 2 equals 30. So only one digit can come in the hundreds place. This 3 comes in the thousands place. So the answer is 3060. The next sum is 235 times 16. So I have two digits here. Each digit has to be multiplied with 235. So 235 times 6 and 235 times 1. So 6 is first multiplied with each digit in 235. The first digit is 5. So 6 times 5 equals 30. And since only one digit can come in the ones place, so I write 0 in the ones place, which is this 0, and this 3 is carried over. Then 3 times, no, then 6 times 3. The next digit. 6 times 3 equals 18. And this 3 is added to 18. 18 plus 3 equals 21. And this 1 comes in the tens place, and this 2 is carried over here. Then I have 6 times 2, the third digit. 6 times 2 equals 12, and this carried over 2 is added to 12. So 12 plus 2 equals 14. So this 4 comes in the hundreds place and 1 comes in the thousands place. This is the first partial product. The next partial product is 235 into times 1. But I am multiplying 235 with 10, as 1 is in the tens place. So it is 235 times 10. So I write 0 as a placeholder in the second partial product, and this 235 times 10. So this 235, I write 5 in the 235 times 1 equals 235. This 5 I write in the tens place, 3 in the hundreds place, and 2 in the thousands place. I add the two partial products. 0 plus 0 equals 0, and 1 plus 5 in the tens place equals 6. 4 plus 3 in the hundreds place equals 7, and 1 plus 2 in the thousands place equals 3. And the final answer is 3760 for 235 times 16. Now let's do a real life word problem on multiplication. So I will read it out. I have 3 boxes and each box has 5 mangoes. How many mangoes do I have in all? So I have 3 boxes. 1, 2 and 3. This box has 5 mangoes. This box has 5 mangoes, and this. How many I have in all? So I know there are 3 boxes and each box has 5 mangoes. So I have to multiply 3 with 5. So multiplication is repeated addition. So I do 5 plus 5 plus 5. 5 3 times added is equal to 15. Or I write 3 times 5 is equal to 15. So in the 3 boxes containing 5 mangoes each, there are 15 mangoes in all.